Guys, how are you? Here is a very interesting question. This substrate is treated with KOH, MOH. Here an elimination reaction will occur. That is H or NME3 group will eliminate and double bond will be formed here. Here the kinetic isotope effect, that is kinetic isotope effect KH by KD equal to 4. We have to determine the mechanism of this reaction. What will be the mechanism of this elimination reaction? So elimination reaction generally proceeds through three mechanisms, that is E1, E2, E1CB. E1CB. E1 means elimination unimolecular, E2 is elimination bimolecular, E1CB means elimination unimolecular via conjugate base. So we have to determine what mechanism it will follow. In E1, when E1 mechanism will occur, E1 mechanism will occur when there is a 3-degree carbocation will be formed. In such case, like if we treat this with KOH, MOH, then one product will be C-CH2, CH3. That means one hydrogen and one Br will eliminate and a double bond will form. This mechanism will follow E1 mechanism because in E1 mechanism it occurs in two steps. How it will occur? First, this C leaving group bond will broken to form a 3-degree carbocation plus Br minus. Now from this carbocation, the solvent itself will act as a base, or maybe the base employed will take one proton to give this double bond, an alkene. Now between these two steps, it is step 1, this is step 2. This is the slow step of this reaction and this is fast. So in slow step only one molecule participate in reaction. So this is unimolecular. So this is E1, that means elimination unimolecular. Now in another example, let's say CH3, CH2, CH2, Br. If it is treated with KOH, MOH, then here also elimination will occur. This hydrogen and this bromine will eliminate. The product will be CH3CH double bond CH2. Now in this mechanism, this reaction will followed in a single step process, that is OH minus will take this photon, this bond will break and bonded electron will be given between this bond and this bond will break. So minus H2 minus Br minus. The product will be CH3 CH double bond CH2. Now here only single step reaction, and in this reaction two components are participating in a reaction. So this is E2, that means elimination bimolecular. bimolecular. Now another one is elimination if it is heated in presence of KOH, then one molecule of water will eliminate and one double bond will form here. This is an alpha beta unsaturated ketone. This is an aldol. So from aldol an elimination reaction takes place and an alpha beta unsaturated ketone will formed. This reaction proceeds in this mechanism, that is here OH minus will take this proton and the corresponding anion will be formed. Now this is a resonance stabilized anion because here the carbonyl group will enter in resonance. So now from this anion one OH will eliminate to form the alkene. Sorry, here CHO, there will be CH. Now here also this is a two-step process. This is step 1, this is step 2. This is the fast step here and this is slow step. So this is actually a reversible reaction. It is the fast reversible reaction and then one OH minus eliminate. So this is the conjugate base of this substrate. So this reaction is called E1CB, that is elimination unimolecular via conjugate base. So now we have to know what is kinetic isotope effect. Kinetic isotope effect. Kinetic isotope effect. So what is kinetic isotope effect? Kinetic isotope effect means if we replace one bond with its isotope and if we observe difference in rate, then that is called kinetic isotope effect. Again I am telling, if we replace one bond which are breaking or formed in reaction, then if we observe any difference in rate, then that is called kinetic isotope effect. Here in our reaction CH bond is breaking, so if we replace this H with deuterium and if we observe any rate difference, then that is called kinetic isotope effect. If the kinetic isotope effect is greater than 2, that means 2 to 8, then that is called primary kinetic isotope effect. Primary kinetic isotope effect. if Kh by Kd greater than 2, but if it is less than 2 or nearly equal to 1, then that is called secondary kinetic isotope effect. Kh by Kd nearly equal to 1. So why primary kinetic isotope effect, secondary kinetic isotope effect? Primary kinetic isotope effect observed when this bond breaking in rate determining step. That means here the CBr bond is breaking. So if we replace this bromine with another isotope of bromine, then we must observe here primary kinetic isotope effect. On the other hand, in E2 reaction, this is a one-step single-step reaction. So this CH bond, if replaced by CD bond, then we must observe the primary kinetic isotope effect. But in case of E1 reaction, here this CH bond is not breaking in slow rate determining step. It is breaking in step 2. So if we replace this CH with deuterium, then we will not observe the rate enhancement greater than nearly equal to 1. We will get nearly equal to 1. That means that this is secondary kinetic isotope effect. So again I am telling, if a bond is breaking in rate determining step, then we will observe primary kinetic isotope effect, and if the bond is not breaking in rate determining step, then we will observe secondary kinetic isotope effect. Now in our question, here Kh by Kd equal to 4. That means it is primary kinetic isotope effect is observed here. So if primary kinetic isotope effect observed, then it must be break in rate determining step. That means it must follow the E2 mechanism, because in E2 mechanism only, this is a single step reaction and this CH bond is broken in rate determining step. So primary kinetic isotope effect will be observed in this case. On the other hand, one more question here, that is here one OMe, here NO2. It is treated with NaOET and our product is we have to determine the mechanism of this reaction, which mechanism it will follow. So here you can see that this hydrogen and this OMe are eliminating, and here we are getting a double bond. Now this is a 2 degree center, because this carbon is connected with 2 carbon and here one NO2 group is there. So what will happen, if a base is employed, then it will take this proton and the corresponding anion will be formed, and which will be stabilized by this nitro group. So if we draw the resonating structure, double bond N, this. So this is a resonance stabilized anion, and which then eliminate one molecule of one OMe and we will get the product. NO2. So you can compare this reaction with E1 or E2 or E1CB mechanism, and by comparing you can observe that this is a conjugate base of this, and so the reaction is E1CB reaction. And this is the slow step when this base is taking one hydrogen, conjugate base is forming. So this is the slow step, and from this conjugate base one OMe will eliminating. This is the first step. So this is the E1CB reaction. Both these questions came in UGC-NET exam. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get such interesting videos, subscribe my channel. Thank you. Have a good day.